Thank you for those of you who are here to be on time. I know you're going to be joined by your colleagues as they rush back into the room, because now we're turning to the truly provocative, non-traditional approach to the integration question of UTM and ATM transition going into the future. Presentations of successful RFI submissions under this realm. Please remember that you can submit questions through the app, and we'll work diligently to try and make sure we get to those and engage you in the audience in a very spirited conversation over the next 90 minutes. Moderators, the floor is yours. Thank you.
Okay, please get your devices ready, because I will also use my mother language. 上一节我们的所有的发言人啊都讲得很好，我们的讨论呢
of excellent presentations, but for our discussion, the panel discussion, is a bit of, I'm sorry, because we don't have adopted any of your questions, but a discussion between our moderator and the key speakers. So this session will give you a time for questions and answers. And our presentation will initiated by friends from Poland and from Czech Republic, and we have the Director of Operations Planning Bureau, Polish Air Navigation Services Agency, with Mr. Pawel and Mr. Tomasz Różyński and Mr. Pawel Korzec, CEO of DroneRadar. And Tomasz is in charge of the operations planning, ATM, UTM, and the operation planning. Pawel is the CEO of DroneRadar, so we are very keen to hear what they have to say, a Polish case. And how do they cooperate to realize a better ATM, the integration of the UTM and ITM? We're all very interested to hear about the presentation, so let's have Tomasz first to present his speech.
Thank you very much for the introduction. Good afternoon. First of all, thank you once again, ICAO, for the opportunity to share with you our experience that we have with DroneRadar, our technology partner, in terms of introducing the UTM and ATM system in Poland. I would like to say a few words about Panza, which I'm representing right now. So we are a Polish air navigation services provider responsible for whole airspace over Poland, and we are providing ATC, so air traffic control services, and also air traffic information control. It is important because I would like to say, and I will have to focus on two very paramount important things, which are, I'm sorry, I'm trying to change the slide. Okay. The communication between involved parties. So, the most important from perspective of NSP is there are basically two things. You probably heard about all INSPs are saying that our highest priority is safety, but still there is a very important element such as performance. So to achieve both of them, you need to have two means of communication and data exchange between the user in terms of manned aviation is radio communication, which provides you a safety, manners, information, and also the information about location. So again, in manned aviation, we are talking about secondary surveillance, coverage, transponders, and so on. Both of those two are impossible to be achieved and to be fulfilled in terms of small UAVs. That is why we'll try to, with Pavel today, present you how we resolve those two issues. First, how we communicate with UAVs, and how we locate them. As you can see on the slide, there is a piece of Polish airspace, because I will talk only about Polish airspace today, although I hope that you will find it interesting and perhaps you will use some of our experience in your state. This is piece of airspace of Poland, there are two important elements: capacity and flight management. Both could be achievable by traffic management, and depending on the location of the area, of the volume airspace where the USV are operating, you can put additional measures on it. So as you can see, I don't know if it's visible, but on the top of the picture there is a tower and the airdrome. So in the closest vicinity, the red area, we expect a usage of our tool, which is called Controller Drone Data Link Communication. So this is the tool when we provide and require a verbal, non-verbal communication between operator and ATC officer or flight information officer. The further you are going, moving from the critical airspace, the requirements are getting more. I'm sorry. Okay. So this is something that we will talk in the next slides about it. As you can see, in the middle of the picture, there is also automation capacity manager. This is only to present that our solution is also very useful, capable to serve for use space, not only UTM, but also on the dense urban airspace. The only change is that we are not providing the service, but there is a DTM, we call it DTM, so this is a drone management service unit, could be provided by a local authority, could be provided by UTM. The decision, again, lies on the side of government. The part of the system we designed is also a drone detection system. Again, this is something, the auxiliary elements of the system. You can put the data into the system and feed the system about the information about the drones which are in a close proximity of the gliding path of the drones. Additionally, the ADS-B receivers, the ground station, as you can see, there are more than one. This is something that allows us to respond for potential lost control scenario and system resilience. If one of the station does not work properly, we can eliminate it and work smoothly further on. There are, of course, still some BVLOS corridors for the aircrafts or UAVs that cannot fulfill our needs. Although this is a step back from our perspective, because then we segregate the airspace, and we would like to avoid that kind of solutions in the future. And this is doable and achievable only if you have a trustful real-time traffic database. And now I would like to invite Pawel to give you a detailed description about the system and its architecture.
So hello, thank you for inviting us for the presentation. Peter, can I answer the most important question asked by the organizers today? The question was how to go from segregation to integration. And I will reply to that question. So, dear audience, I would like to tell you that there is only one solution to integrate both, by limiting the number of data that we show to ITM. That means that we need to show only dedicated information which will be valuable for the ATM. This is our answer, actually. And why I'm saying that on that picture, because we can aggregate all of this data. I mean, gathering the data from different, data sources is relatively very easy, but to make a decision out of this data, this is the clue, and this is the heart of the UTM system, which would need to be built all over the world today. So we gather all of this information, and by providing dedicated consoles to various users, for instance, to the ATM users, or to the city users, or U-space users who manage the airspaces in G-space from the perspective from the airspace, but they manage their own airspaces around the stadiums, buildings, and so on. We have created a couple of dedicated consoles with the different interface with the hierarchy of the user rights, which means that, of course, the CTR controller has a bigger right than actually the person from the city. Those requests, all corridors, those all requests are visible in one system, and it can be managed by the authorized personnel. So, why we are showing that? Actually, we decided not to show the traffic to the air traffic controllers. When we started discussion with them, they told us, no, this is too much. What I can do if I see 100 drones or 50 drones? So our strategy is to show only those drones who failed, who lost C2 link control, and those drones under which we do not have any control. And believe me, those ATC controllers that we are working on with Panza, they like the idea. And this was the day when they changed the approach to the drone by the end of the day. So we are showing those information which are critical, important, and have emergency or safety influence by the end of the day. So what is our contribution to ICAO today? By analogy to the CPDLC, Controller Pilot Data Link Communication, which were used basically to avoid the mistakes, human mistakes in hearing in the radio communication, we would like to suggest something which is called Controller Drone Data Link Communication. Controller Drone Data Link Communication is actually the system which will ensure that the air traffic controller can in a safe way communicate in 3 following scenarios: drone controller, controller to the drone or operator, and emergency situation. So this protocol we have developed 2 years ago, and it's now implemented operational in Poland for 1.5 years. We, in each communication, we guarantee that the message is delivered, read, understood, and executed. And this is something which is not something similar to the radio communication used by the ATC, but once we guarantee that the traffic controller has the right information, they started to use the system actually. And one thing more, the critical part of this system is the data, access to the database with the registration. So critical data are competencies of the drone operator, insurance, and drone features which are certified. So at that moment, whenever the drone ATC controller make a decision, either to launch the return to home or advise to launch the return to home, he will get the message about the certified and authorized capabilities of the drone. Okay? So this is how we would like to contribute. We reviewed the JAR proposal, Whiskey Golf 5, and it's very, very common to that. Also, this might be used for SOAR analysis. And just to make difficult word very simple, we created the recommendation table for our users, and depending on where areas where they fly according to the airspace encounter categories proposed by EASA, the user very simply can understand in which equipment is needed for a flight in particular place.
So we're getting to the conclusion. This is an information that we received and obtained from the users after 2 years of tests, because there were more than 1.5 years, because we started with a very early premature product, and afterwards we developed it during this test. Finally, what is the most important? Still, the safety is our highest priority, but we understand that without such tool, it will be hard to achieve a performance at the required by users level. We as an ATCO or flight information operators are only willing to receive the information in a wise way, not all information. At the beginning we thought, give us all data, everything you got, all information, velocity, speed, rate of climb, almost everything. But afterwards we realized that we don't know what to do with it and we don't need it. And it basically decreased our productivity and the workload is growing unnecessarily. So non-verbal communication finally give us a possibility to reduce communication time, because we can focus still on the communication between the manned aviation, the awareness, the increase of awareness among all players, not only UAV, and of course the involvement of the amateur users. This is also very important. That's why we highlight still that educational activities are highly appreciated. During Warsaw conference, if I remember correctly, in late 2016, there was very good statement that still the education is a key element, because there will be new players on the theater of aviation and they are not fully aware about our language and about our habits and requirements. That's why the education is still very important. And we call it positive shield approach. This is something we would like to present, that we believe still very much that it is extremely important to communicate with the players before they execute the operation. That's why we started in Poland nearly 3 years ago, a very active public media, social media campaign about how to fly within the proximity of our airdromes. Separation management triangle, it's something you can see. So prior to the operation, we expect to, if needed, segregate or at least somehow space the traffic from the critical path in terms of CTR operation, so operation within control zones. Afterwards, we expect that there will be some still segregation, but this is a subject for further investigation because, as you all know, there is still a regulatory framework ongoing, but we have to face the reality and the time and the expectation of the users. And finally, on the very top, the white triangle should be light blue, but still there is an ATCOS, so someone who takes care about your safety as a passenger and also the safety of all US operators. And finally, the cherry on the top, this is something we would like to share with you. This is the outcomes of tests we did in June this year. And I would like to ask again Pawel to explain you the outcomes.
Yeah, and this is the closing speech. I will take 60 seconds, not more. So what we wanted to check. So actually, we gave the task very simple to make autonomous flights using ADS-B transponders, and we checked if we can create the regulatory framework that will be understood by people and implemented. And what has happened? We invited 6 academic teams, and believe me that in 2 weeks they have implemented this very simple scenario based on the virtual sphere of the around the drone, based on the momentum, which means the mass multiply the speed. They implemented that. They were flying all in the one airspace. We were looking for violation of the rule for leaving the geo-spaced area, and simply we proved that we can create as let's say recommendation for regulatory framework that they will implement autonomous regulation actually. So this is what we wanted to show. We proved that, and we share this information with our Civil Aviation Authority, and we'd like to contribute to the world with that. So thank you very much, and wish you a good day.
Thank you.
Our next speaker is Marc Gay. He is the CEO of Unifly in Belgium. He holds a master's degree in electronics engineering and business administration. He has built a career in scaling unique companies from an idea to a leader in their field. He has an EASA commercial pilot license and is a flight instructor. Marc is the vice president of GUTMA, the Global UTM Association, who's spoken here earlier on. His presentation will focus on one key element of UTM, situational awareness. How can UTM ATM integration increase situational awareness for all stakeholders? He will explore how Unifly technology can be used in that area, but will also touch on the issues from a regulatory point of view. Marc, the floor is yours.
Thank you very much, Peter, for this nice introduction. I would like to start my presentation with a small story, something that happened to me already 5 years ago. I was flying a small aircraft in uncontrolled airspace. As a flight instructor, I was teaching someone to fly. And the exercise that we were doing was simulated forced landing. So typically, that's an exercise where you fly at 1,500 feet, you put the engine to idle, and then the student needs to react correctly. He needs to fly the airplane, find the landing spot, and approach that landing area. So typically you go to 500, maybe 400 feet. Everything went well. We went back to the flight school. And as I got out of the plane, my secretary came up to me and said, Mr. Kegelaers, could you please come and talk to the phone? Because there's someone that really wants to talk to you. So I pick up the phone, and on the other side, there's a guy who says, are you the pilot that was flying this aircraft over St. Job half an hour ago? I said, yeah, that's me. And then he started to express his feelings about me in words that I cannot repeat in this platform, but he was unhappy.
So apparently what had happened is that was a scientist that was flying quite a sizable drone with very expensive measuring equipment in uncontrolled airspace. And I nearly hit it. I nearly destroyed about $50,000 worth of equipment. And I nearly died in the process. And if there's one reason why I'm in the UTM business, it's this. I've gone through the experience of having a nearly miss with a drone, although I was not aware of it at that time. And there's a problem. None of the parties involved had any situational awareness. I was not aware that there was going to be a drone flying there. I didn't see it. I was in contact with air traffic control. They didn't know that there was a drone flying there. The drone pilot, well, he saw me coming. He was very much aware, but only when it was far too late. So that's one of the key issues that the UTM system must resolve, and that's situational awareness for all parties involved. So some of the things that we'd like to do is, before the flight, we would like the drone pilots to state their intentions, sort of file a flight plan. And then during the flight, it's essential that we know where the drones are. We would also need to know where the manned aircraft are. Ideally, we would like to do some conflict resolving. And then we would like to be able to communicate with drone operators and aircraft pilots. So that was, let's say, the increase of situational awareness that we'd like to achieve. Now, we as a software company, we've had the vision of wanting to create a software architecture that more or less looks like this. We wanted to have a core product that could be accessible through application programming interfaces, but it would have to serve the needs of all parties involved, and we should not be forgetting anyone. So manned aviation gets affected by drones, so we need to serve their needs. Drone users, we need to, let's say, take into account all the drone users. So end users need to be informed about aviation regulations. Professional drone users need to be able to plan flights. And the authorities need to be involved. And I'm not only talking about aviation authorities, but also local authorities. Once you go to urban aerial mobility, then the sheriffs or the responsibles for the towns, they will want to have some involvement of knowing where the drones are and potentially giving access to airspace, yea or nay. And then also we want to talk to the drones themselves. Once you go to a fully automated environment, that becomes one of the stakeholders. Now, how does it look like? How have we implemented this? At the core, we see an application which is typically cloud-based. We've built an architecture that it sits in the cloud, very resilient, very high powerful. On the top of the slide, you see ATM. We've done a design, one of the basic design elements of our system is that we would talk to ATM. So we are already stream compliant, have been since 2014. So typically we use the protocols like Asterix and AIXM to exchange information with the ATM systems. We can pull in all sorts of GIS data, being obstacles, being no-fly zones, being railways, roads and so on, to determine if a drone can fly somewhere, yes or no. And then we've also created a technology so that we can take a national regulation or a regional regulation and put that in a database format so that we can start to make decisions of should a drone fly here, yes or no. Now, we've developed a number of user interfaces for that data. So typically we have web applications that can be used by professional drone pilots to plan their flights and ask for flight approvals. We have mobile applications that can be used by private users. Then on the right side, we have a number of terminals and functions that can be used by administrators of the authorities, administrators of the ANSPs, and even administrators of local cities to know where the drones are, create no drone zones on the fly, do database management, define the drones, the pilots, and so on. So all the data that you would need can be filled in by those stations. And on the bottom, we want to connect to drone tracking infrastructures. Now, ultimately, the ultimate goal that we had is we want to create situational awareness for all of the parties involved. And this is one of the screens that we have on our system. So we visualize manned aviation. So we get the data from the Asterix interface and we can visualize a manned aviation. We can also visualize unmanned aviation if we have the tracking information. Now we will only show the potential conflicts, so there's a lot of filtering. We can define or visualize airspace or even dynamic airspace. So imagine a situation where a local authority defines a no-drone zone on the fly because of an accident. Well, that will be visual. And the green spots that you see in the screens are typically something that is also feasible. We have various levels of information that we can put on that screen, and those green spots typically are the no-drone zones over natural parks, in this case in Germany. So that type of information we can show as well. Within this part of the application, we can do some deconfliction, unmanned versus unmanned. If they get too close together, we raise alarms. Unmanned versus manned, we raise alarms. But also if unmanned traffic goes into no drone zones. Plus we've built in some replay functionality, so after the fact you can also visualize what has happened in case there are any complaints or conflicts. That same information we can also provide to the end user. So the end user that is flying somewhere in the middle of nowhere can be notified that there's another drone or manned aviation coming close by. And that same information we can provide to professional drone users or even operation centers of large drone users that want to monitor where their drones are and if there are any conflicts. So the same data, and depending on the type of user, we can show different user interfaces. Now, one element for situational awareness is that you need a tracking technology. Now we've seen that there's no fit for all today. Depending on the situation, we have worked with satellite communication. We've worked with low-powered ADS-B signals. We've worked with devices that provide us a GPS location via an LTE network. We are compatible with FLARM. We've done things with the ground control stations. We have some interfaces to drone radar systems and even tracking applications. So there's no fit for all, which to me is a challenge for the regulator. Now, how do you regulate this tracking? We are used in unmanned aviation that we have prescriptive regulations saying, thou shalt use this technology for tracking or for something. How are we going to do this in a world where there's no one fit for all? And maybe we need performance-based regulations saying that in situation A, we need X amount of performance and X amount of availability from certain technologies. So what will be the acceptable means of compliance to do the tracking is to have tracking so you can actually use it for deconfliction. So once you've defined that, how are we going to test that? How are we going to validate that? How are we going to certify that? Big questions that we as an industry are currently looking for. One initiative that I've seen in the world, which is very promising, is that we are now also a partner in the New Air test site. They've developed an environment where you can actually do a lot of testing and a lot of certification to do this certification. So some of the reference that we have, our technology is already being used by a number of ANSPs in the world as the basis of their national UTM system. Within Europe, there's a lot of research being done for U-Space. We are currently contracted in 7 major research programs that all have to do with defining U-Space and implementing and demonstrating U-Space. And I can announce that there's 3 more projects that we are about to win. So about 4 weeks from now, we should be able to actually increase this list. We have a global reach. We have some activities going on in the United States. We have some activities going on in Africa. We have activities going on in Japan. But the key element in all of what we're doing is we are actively looking for partnerships, and that's one of the reasons why we were one of the founders of the Global UTM Association. UTM is a very complex thing, and it will not be one single company that will be able to make everything. We are a very good software supplier, but there's a lot of other things that need to be done. We have built relationships with several organizations, one of which is here, which provide us 3D data to do urban aerial management. Google X, we are partnering with for the inter-USS Huawei is a strategic partner for us for the LTE connectivity in our new air, where we will be supplying some of the management software for that drone corridor. One final remark about this presentation. I told you a story about what happened to me in 2013. Well, the guy on the other side of the phone, afterwards I learned about him, he's Koen Meuleman. He become one of the co-founders of Unifly, and he was on the board. Thank you very much.
Okay, thank you so much, Mark. I switch to my mother language. 我们下一位发言人呢是 Lindsay。You ready? Lindsay 呢，我想如果把她的简
If we have a resume on Lindsay, to summarize Lindsay's resume, we'll call him a study genius, academic genius, because he has majored many majors such as the software development and others, and also cross-border interdisciplinary development, because he has majored in many fields and has also coordinated his effort in this area. And next we'll hear from this academic genius from Canada. He will also talk about blockchain, the concept into this topic and discussion. And we really look forward to his presentation. So let's give the floor to Lindsay.
I'm Lindsay Mohr, CEO of AirMarket. We're a software solution provider focused on the drone compliance space out of Edmonton, Alberta, Canada. This presentation is our white paper, which is a collaborative effort with Distributed Sky out of San Francisco and TerraHub out of Calgary, Alberta. So the contents, what am I going to talk about today? I'm going to address the following aspects. We're going to talk about the challenge, geofencing and communications, UTM system architecture, the implementation roadmap, and touch on a little bit of the work that we've done so far. If we turn our preview to the challenge, the red space represents the manned aviation envelope for which this organization, ICAO, has been created to serve. The air traffic management space, or ATM, is a centralized system with airports at the hubs. Air navigation service providers, ANSPs, ensure safe operations with their air traffic control personnel. The yellow space represents an area of anxiety and concern and challenge for us this week. This zone identifies an area of transition for which the accountability for deconfliction and safe operations are likely to be transferred. Geofencing provides a detection mechanism and is based upon ATM components such as controlled and restricted airspace, NOTAMs, and TFRs. The green space represents a frontier of opportunity and challenge for which we assemble this week. Due to many contributing factors, the pace of technology, the development of advanced manufacturing, just to name a couple, the UTM, or unmanned traffic management sector, is widely accepted to be a decentralized system. Moving from left to right in the green space, the population density increases, and so does the potential risk. This induces the expectation for predetermined or automated controls to effectively manage that risk, and therefore accurate data, reliable communications with the UAS become essential requirements. So these factors support the decentralization of UTM service delivery, and we suggest result in three critical requirements: the importance of inter-USS communications, 2, the demand for the single source of truth, and 3, the immutable transfer of liability. Geofencing functions as the basis for defining, identifying, and enforcing boundaries with UTM and between ATM and UTM. We propose an onboard capability for geofence enforcement and bidirectional communication. Fixed and temporary boundaries are used to define geofences. Fixed boundaries include controlled airspace, controlled and restricted airspace, as per existing ATM definitions. In comparison, temporary boundaries are dynamic and shall be defined by existing ATM components, such as NOTAMs and TFRs, and 2, planned UTM flight activities. Adopting the NASA geofencing strategy, a 3-layer concept is proposed for the classification of geofences. Alert, alarm, and terminate layers, as illustrated in the graphic. Included in the geofence definitions are the actions to be taken upon fence breach. These actions can be mandated and configured to meet jurisdictional requirements. The ownership and management is anticipated to reside with national aviation authorities, with the delegation of geofencing powers to authorized entities, which may include USS, federal agencies, ANSPs, and emergency organizations. We propose both an onboard and remote implementation strategy. An onboard geofencing agent, such as NASA Safeguard, will function as a redundant safety system to ensure geofence enforcement is achieved. Satellite or cellular communication with the UAS will enable real-time dynamic geofencing capabilities. The ability to communicate with the UAS enables remote access, and coupled with smart contracts, which will be discussed in the next slide, can provide a framework for pre-authorized flight overrides. This will empower USS and or ANSPs to terminate flights based on geofence breaches for the protection of ATM and UTM traffic. This slide will depict the proposed UTM architecture for which distributed technologies are proposed. The technologies are generically referred to as blockchain, but reality is a composition of supportive or collaborative technologies. We are proposing the adoption of a public distributed ledger system. To help position and clearly identify our proposal, I'm going to offer a UTM analogy, or an ATM analogy. We propose the creation of a distributed, virtual, configurable aircraft flight recorder for the UTM solution space. This proposed solution will provide member states with the capabilities to identify, record, and forensically audit transactions within the UTM and ATM systems. It must be noted this is a proposed solution, is not intended to as a replacement strategy, but one of support of existing service or new services. The authorization layer provides the capability to uniquely identify all stakeholders and their associated performance parameters. Using cryptography, each node or entity is provided a globally unique identifier for which all system interactions are recorded against. The business logic layer provides the differentiating capabilities of our proposed solutions. Smart contracts provide a configurable mechanism to record economically or operationally meaningful transactions. The unique identified stakeholders will enter into agreements that contain specific parameters. Smart contracts are simply a template that can be defined and shared by any entity in the network. The capability empowers regulators and member states to co-define the basis of UTM agreements to govern the system, while enabling jurisdictional customization as required. Contracts are shared into the distributed ledger by replication to all parties in the network. The network achieves a state of consensus upon confirmation that all ledgers have the exact same version of the contract. The inherent characteristics provide a single source of truth, which is mission critical for industry safety. Once consensus is achieved, the transaction is appended or linked to the previous transaction block using cryptography. Subsequent transaction blocks are linked to form a mutable chain of transactions called the blockchain. The technical infrastructure layer provides data storage and a mechanism for monetization. Member states have the implementation choice for a fully distributed data storage where storage takes place across all network nodes, or a more traditional cloud-based storage scheme. The ability to monetize this system is inherently delivered with the use of distributed ledger and smart contracts technologies. The exchange of cryptocurrencies and implementation option for consideration, which should greatly increase the overall efficiency and reduce the total cost of ownership should this be considered. So, to apply this to the UTM context, I'll describe just a couple sample interactions that could be facilitated by this architecture. Number one, the USS agrees within a smart contract to provide flight management services to a UAS operator and includes strategic deconfliction activities. The ANSP provides approval for associated conditions within a smart contract for the USS to manage an unmanned flight that enters into controlled airspace. And lastly, the UAS operator purchases meteorological data from a supplementary data supplier using a smart contract. Our proposed implementation roadmap has 6 distinct capability-focused milestones. The pace of reaching these milestones are influenced by 2 key aspects. Accommodation versus integration is a matter of a technology adoption, and ground versus airborne decision-making is a matter of technology development. The first milestone establishes the basic deconfliction using 4D geospatial evaluation and relies on 3 essential services: distributed data, aviation data, and a flight notification service. Milestone 2 is differentiated by UAS connectivity for real-time data positioning and establishes UTM monitoring service. Milestone 3 establishes 2-way connectivity with the UAS and enables rapid intervention capabilities and leverages the geofencing service. Milestone 4 can be viewed as the initial UAS integration marker with the use of machine learning and artificial intelligence disciplines. Predictive deconfliction can be delivered via flight optimization service. Milestone 5 achieves peer-to-peer connectivity and provides an onboard redundant safety system with detect and avoid capabilities. And lastly, milestone 6 enables UAS to directly interact with the distributed architecture and perform deconfliction activities via onboard compute, and is supported by a local swarm coordination service. Now, I'd offer this roadmap serves to identify potential domains of collaborative industry research, and which could include network communication modeling, machine learning, artificial intelligence for predictive deconfliction, and a flight optimization, just to name a few potential areas of research. To summarize, our response to Drone Enable 2 request for information has described a geofencing implementation strategy that identifies ATM and UTM boundaries and a method for managing the transition. The essential capabilities required are communication that uses reliable channels to ensure all parties interact within the networks. Trust is established when data is consistent across the networks. And then lastly, accountable. Accountable parties perform legally binding interactions within the networks. To wrap up, the work done to date, we are launching our enterprise drone management platform called FlySafe. We are releasing this week a second iteration of our white paper that's co-written with Distributed Sky. We are kicking off a pilot project and we're testing NASA Safeguard and Geo Networks technologies. We've established a collaborative network of companies that are working together. You can see them there. And lastly, we are fostering the vision in Canada to have a UTM test bed. And with that, I thank you very much for the opportunity.
Really interesting stuff. You lost me here and there. That'll come up with the questions. Next speaker, Patricia. In ICAO, we're supposed to be balancing female and male participation in everything. This is a total disaster here. You're the only one. I would like to tell the audience, I did not put Patricia at the end, neither did Leo Howell, but she ends up at the end. I'm sorry for this. Now, Patricia is an engineering manager at the International ATM and UTM department of Indra in Spain. Indra has a vast experience in ATM and in ATM with installations all around the world. After multiple requests by its customers in the recent years, Indra has created a new U-Space and UTM department, and today Patricia is going to present Indra's vision in the field of ATM and UTM integration. The floor is yours.
Hello, everybody. Thank you for the kind presentation. Today, I'm going to talk about our vision, Indra's vision, in ATM and UTM integration. Before starting, I would like to introduce some figures about our presence in ATM business. We have 4,000 facilities in over 160 countries. So that's a lot because the world has around 200. We cover the whole portfolio of ATM products, from automation to radars, communication systems, everything. We are always innovating and developing new products, and now we are developing UTM solutions. But today, I would like to talk about this integration between the traditional ATM world and the new UTM. Here we have another infography of airspace, we have an airport that is in airspace class C or D, and we see that there is a city nearby. The drones today will fly mostly in very low-level airspace, but what happens if I live in a house in the blue area and I want a drone delivery? The process is very hard. There are a lot of special authorization, a lot of restrictions, and it's very difficult to fly in these areas. So we can extend the very low level and reduce the area of influence of the airport. But these have several problems. We have an overlapping between these two areas, the blue one that is controlled by the ATM system and the green one that is controlled by the UTM. And this can cause lots of problems or incidents. So we have several solutions for this, like the lands in the United States, or we can redefine the whole airspace structure. But this is difficult and it's a long process. So my proposal is to get a complete integration between ATM and UTM, a complete and seamless integration in order to avoid problems in the overlapping areas. The integration, we have made some assumptions about this integration. First, this integration is for drones flying in very low level or in airspace classes F and G that are close to controlled airspace. I'm not talking here about big drones flying in controlled airspace that if they are properly equipped, they can be treated as manned aircraft. And also, and I think this assumption is one of the most important, the drone pilot is the responsible of the separation of the drone with other vehicles or obstacles. The ATM control is not responsible of separate drones. Now, 3 key points about the integration. The first one is that we try to minimize changes in ATM systems. ATM systems are very complex and changes are very expensive and difficult and can impact on the safety. So we try to minimize these changes. Our approach is compatible with the US Space Roadmap that is developed in Europe by CESAR, and also the integration follows a gradual deployment because also the traffic drone will increase in the following years, so we follow this growth of the market in our integration. Now I'm going to start with the 4 phases of this integration. The phase 1 can be the current situation in most of the countries. Most of the countries don't have an UTM system, and if they do have an UTM system, this is totally isolated from the ATM. This is causing some problems. Every day we can see in the newspaper that some drone is going close to an airport, and there are a lot of problems. So we propose in this first phase to install an UTM auxiliary display in the control centers in order to have the information about the drones in the area of the airport or control center. Then also we propose to start training controllers into drones, the performance and the movement by including drones in the simulation for training. Also, for the more critical infrastructures like an airport or maybe government buildings, we can deploy counter-drone solutions to get a solution right now and don't have to wait. This phase, as I said before, is not very safe, so it should be as short as possible. Phase 2 has to be deployed quickly. The phase 2, in the phase 2, ATM and UTM start sharing information. In this phase, we share the tracking or location of the drones and the identification information. As I said before, we try to minimize change to ATM, so we try to use current protocols or current standards. Having the identification information and the location of the drone, the controller has the complete picture of the air situation, and in case of an emergency or a special situation, he can contact using this identification information. This phase, we plan to be deployed in 2020. The phase 3 is a big jump. A lot of information is shared. We add to the location and identification in phase 1. We now add alerts, drone missions or drone flight plans, all the geofence information and the possibility of creation of geofencing from the ATM system, and also communication via message or using the current communication system like voice over IP. With this information in the control center, we have the complete picture of the situation now, but we also have information about what is the plan, what will happen in the next few minutes, and we can plan accordingly. We know that this is lots of information for the controllers, and the controllers don't want a lot of information. So this information needs to be filtered, and only the essential one has to be displayed in the control centers. The phase 4 is the final phase where we have a complete and seamless integration between the two systems. The information is exchanged automatically. There is silent coordination between them, and here we add a new functionality that, as I said before, the drone pilot is the responsible of the separation, but we think that in some emergency or very exceptional situations, the controller may want to give an authorization or a clearance to a drone. So we give the possibility of give specific commands like clear the area or something like that from ATM to the drone pilot. This phase is very far away in the time, and there is uncertainty, and the deployment may change with the years. And we think that this phase will be deployed with U3 or U4 services of US space. To finish, I would like to talk about some projects where we are working in these phases. In Europe, we are working in the Safe Drone project that we are leading, that is a new space demonstration. And during this project, we plan to reach the phase 2 of the integration. We are also, it's still in proposal phase, but we will also participate in the Tomasz project that is led by ENAIRE, that is the Spanish NSP. And this is a more ambitious project, and we plan to reach an early phase 3. We plan to share more information. Also, with some of our international clients, we are doing some pilot programs of the integration, and also, and this one is important here, we are doing an integration survey. As I said before, we know that the controllers don't like to have lots of information, so we are going to ask them what information they want to see, how they want to see this information. This information shall be displayed in the controller position or to the supervisor or a new special position. So we need these answers in order to improve and redefine our phases. So we are conducting a survey, and if you want to participate and give us your feedback, you can write me, and I will be happy to include you in the distribution list. The results, we plan to have it for the beginning of next year. So that's all, thank you very much.
Thank you very much, Patricia. What are you doing, Hal?
You may say some words, and I'm reading the questions from the floor.
Okay. So while Hal is doing that, let me ask a quick question from Patricia. You were the last up, first question. Your phase 1 and phase 2 seem extremely limited in their output and what they're actually supplying. Why is this taking so long?
Yes, they seem limited, but really they are not limited, I think. Phase 1 is current situation now, that is creating very unsafe situation, but with the adding of the auxiliary display, we are improving the situation. And in phase 2, with the tracking and identification information, I think that the situational awareness is highly increased, and the situation is much better than the current one.
Okay. Follow-on question, and then I'll let Hal go. Your survey, is that going to be made public, the results?
Yes, we plan to make public the results.
Very good. You ready?
Yes, we have several questions from the floor. Okay, this one is very interesting. Can the presenters please comment on the merits, similarities of their colleagues' proposed solutions? In Chinese, we may say, 互黑的时刻到了，开始吧。Okay, please, you may give comment to your colleagues.
Okay, let me fire this one off. What are the differences between the various solutions? I will not criticize colleagues or colleagues, there are different approaches. I think that the drone radar and our approach is very similar, maybe in a different level of implementation. I think that the industry as a whole is trying to find good solutions. There are a number of things that are becoming very, very clear. Technology solutions will have to be cloud-based, will have to be very secure, will have to be very scalable. And I think that a number of companies in this industry are starting to produce this. So that's my view.
I'll echo those comments. I think on stage, I think I was the most non-traditional topic put up, and I think that's what was presented was a very UTM USS service suppliers up here on stage. Before the presentation before, I think there was very ATM focused service suppliers and coming from that industry. And so we chose to focus on data and immutable transfer of data. And I think that's a very non-traditional topic that hasn't been raised yet before. So diversity.
Peter, please use your microphone because otherwise
That was not the question.
Okay, I didn't hear
The
it,
question
sorry.
was, can you comment on your colleagues here on what they're proposing? We didn't ask for a commercial from you.
I wasn't trying to give one.
No. But what do you think about the Polish solution? What do you think about the Unifly solution? What do you think about the Indra solution? That was the question.
I think they're really doing stuff, right? That's what I got out of the Polish presentation. Marc is absolutely getting traction and driving capabilities with countries and driving the questions and getting answers. And also with Indra, I felt that they had a start of a great platform.
Yeah, okay, thank you. From our perspective, I think it's a matter of maturity of the products and the way how we understand the UTM and the final user of UTM. For us, it's still an NSP because we own the data. All data that you need to feed the system, let's call it to feed the system, the UTM system, are today in hands of NSP. Of course, there should be some additional sources such as GIS, so the information about obstacles, data terrain, that's always accessible, so it could be introduced in the system. But still, the key issue is the still aviation information. That's our perspective. I like the presentation of Patricia, the most, gentlemen, and because it's very similar, not only because that Indra is our ATM system supplier, but also because this is what we already tested, and we think it's a good way and good direction. We use auxiliary system, additional screen on CWP, so on controller working position, and for the time being, when I say for the time being means probably it will change in the future when the automation will be more available, but for today I think it's a good way of thinking about UTM.
Let me be honest with you guys and gentlemen. I like very much what you have shown. And I see one common thing is that each of you has put some effort on one dedicated thing. And as I know in all aviation world, the devil dreams in the details. And I would like ICAO by the end of this day that they will choose the best experience, best things out of all of this presentation and to make the global regulation. And why I'm saying that, I had the occasion to travel by train from Warsaw to Vienna in Austria, in Europe. And can you imagine that on each border they were changing the machine, the people, the bar, and the ticket checkers? You know, if we will not make the one standard, best of breed, best of what we present, this will be the same with the drones, and this is what we need to avoid.
Yes, I really like the presentation of my colleagues about the one that you made is a very innovative system, and I like it, but our solution contemplates the integration of all kinds of solutions, so it's okay. I think that we can manage to integrate also this with the ATM. About the one of Marc, I think that we have some point of common about increasing the situational awareness in the ATC, and I think it's very important to avoid incidents or unsafe situations. And about DroneRadar, I already have been talking these days with the guys, and I think that they are doing a very good job putting in operation a real UTM in Europe, so I really like the presentations.
No, I'm finished.
Okay, good. We also have some questions from the floor, which are quite nice questions. Okay, we will have the first one. What do you think as small and medium companies need from regulators to scale your business? Clear?
Hello. What do we need as a small to medium-sized company from regulators to grow the business? Clear rules and clear definitions. I think this, all of us in this industry, we are spending a lot of money on trying to develop stuff. But there's a real danger here that if we start developing something which makes a lot of sense, and then the regulation goes in a different direction, and we will have spent a lot of money. So we're looking at the regulators to help us, but I think it's a two-edged sword. We are very innovative companies. We are bringing new concepts to the table, and one of the, let's say, one of the roles of innovators is to actually educate regulators of what is possible today from a technology point of view. I think that this is the initiative, this very valuable initiative where we can actually show what is coming and what is possible. But yes, regulators, please do regulate it in a way that we can drive this industry forward.
So if I was to summarize it, I'd put it into one word, and I'd say courage. Courage to fail, courage to succeed, courage to put funding on the table, and I can talk to the experience in Canada, the courage to move forward and change today. I come here and I'm astonished, the Chinese presentation, right? They've done a great job. Singapore, they're doing a great job. My colleagues on the stage. So comes back to courage and to realize that there's economic benefit there. And you want to, as a government, you want to help your people create jobs. And that's one of the motivators I would ask.
Well, my company is quite big, I think, but I think that I agree with both of you that the regulators need to act quickly, and they need the advice of us, of the industry, in order to progress quickly in this regulation to boost the potential economic of all the drone market.
I would like regulators to be brave by the end of the day.
Please close.
Yeah, I would like regulators to be brave by the end of the day. I mean, this is the huge responsibility, and we cannot, you know, destroy the good reputation of aviation and being brave in the same being wise. So this is what I would like to say to the regulator.
I'm representing NSP, so I feel more rather like a customer, potential customers of your solution. So my plea to regulators would be, again, be brave, because otherwise we'll stuck where we are. For example, we are also responsible for CNS, for communication, navigation, surveillance infrastructure, and there is a need to introduce additional means of navigation. And without a regulatory framework or a decision which direction we should go. We cannot afford to test and to buy everything. So the question is when and why so late we will receive some final information, some regulation framework that will allow us to spend our money in the wise way, sorry.
Okay, Peter, I will continue. We also have a quite hot question. We got so many support for this one. Please provide your viewpoint, perspective on how emergency or contingencies, for example, a failure of part of the UTM system would be addressed, risk mitigated. How would such a failure be coordinated with the ATM system?
Well, I think that this is a very hard question, but I think that we need to keep UTM system as safe as ATM systems are now. We need redundancy, we need to make a risk assessment, and we need to be sure of, in case of failure, everything is going to be okay. Also, with integration with ATM, in case the UTM system fails, we have, in our solution, we have the option of controllers start doing some things in order to clear their space until the solution is solved.
I'll build on that. And let's be honest, we're probably going to be piloting for the next 3 years. And we're going to be taking lessons from ATM. And we're going to be taking those lessons and all of that knowledge and bringing it in and making the redundancy and having the service levels that are going to be required by our regulators. So it's going to be a grow. We're going to have to grow and know.
Yeah, it's a very good question, and it's one that, let's say, kept us very busy from the day one. And the architecture that we have created is actually a fully fault-tolerant architecture. We have multiple nodes on which our software is running. And some of the things that we are doing, we provide software, and in some cases the ANSP want to have our software running on their cloud environment. We have some requirements on the performance of of that hardware, the performance of the underlying operating system, the number of nodes that we want, and so on. So far in our environment, we have had our software up and running for 2.5 years. We've not had one single down period so far, so we're quite happy. We're quite proud of that.
So please let me put the ATM perspective as we talk about the UTM and ATM integration. I mean, this will work when one day all of these procedures will land as operational procedure on the table of the air traffic controller. And we need to do anything that this will be certified, approved, to lay on the table of the air traffic controller that he will believe what he see out of our systems actually. And this certification process may last 6 months or 7 years. We need to make quickly as possible.
So referring to all what my colleagues already said, for experience today, our system that we already deployed covers also emergency situation. Thanks to non-verbal communication functions, we can communicate with the operator by one single button. So there are 2 buttons. One is called panic button. The second one is red button. The one is responsible for sending information about lost control traffic, and the second or the first, sorry, is in a way an order to the operator land because there is some emerging situation going on. So the system, as you all said, are feasible to support that kind of operation also.
Okay, before I give the floor to Peter, I would like help our colleague to ask one more question. That is question. Okay. What steps do ANSP need to prepare or be concerned with ATM and UTM, given that no one solution or standard exists?
This is a very good question, but
Especially to you.
especially to me. As I said, we need for sure the regulatory framework, but because it does not exist yet, we're having two separate systems. So the life cycle of the ATM is going with their own nature, and the other system is trying to catch up all requirements on needs of the user, and this is the only way how to do it. But this is an operational perspective. But without framework, we're still chasing in a way that we are not sure that this is a proper direction.
So far I work with the ANSP for more than 16 years, and I can only say one thing: there is only one step needed to this. To integrate those systems, we need to create the trust between ATM and what we are doing actually. And if the trust will exist, then we will move forward.
Okay, the question was, how should an ANSP approach implementing UTM, ATM system, given the fact that there are no standards yet? Well, they should work with companies that are working on creating standards and provide good information, and that's one of the areas that we have been investing huge amounts of time and effort in. And that's the reason why we participate in the Global UTM Association. It's an association of a large number of companies that all want to have the same thing, international standards, so that we have a common way of thinking about UTM, so that all the ANSPs in the world, and all the UTM service providers in the world have a common vision of what UTM is. So yeah, that's the advice that I would give.
I'll use a bit of the Canada experience is the need or the understanding that you need to do something, right? And realize that there's going to be multiple players that you're going to have to engage with, and you're going to have to pull from companies that are doing it, and you're going to have to build services that are exchangeable, and you're going to realize on that and put resources to start that journey.
Yes, I agree with Marc that the standards are needed, and almost all industry is working with good association and so on. And for the ANSP, I think they have to act. They cannot wait to the standards because it's a long process and very slow. So they need to make a decision and stick to it by the moment, and we will have to modify giving the future step. But today we have to start acting to make possible the drone market.
Okay, thank you. Peter, would you like to ask some question to our panelists?
Yes. We now are bringing out the word standards. Now it's coming. It's taking years to get something. Now, what do you think on your side, as far as UTM is concerned, could be done to accelerate the creation of standards and possibly prioritize, first of all, the standards required and then accelerate their production?
Well, I think that there's already a lot of stuff happening. Standards have the objective of becoming interoperable. And one of the very good things that is happening specifically in Europe is that all of these demonstration projects that have been defined, and they do take some time. But in some of the projects that are happening right now, and that will be allocated over the next several weeks, we will be working with national authorities, local authorities, all the UTM service suppliers, and those really are the test beds of what is achievable in a short time frame. And I think that in this case, the standards will be defined based on experience, international experience with a lot of international companies trying to find out, okay, how is this going to be possible? So that will drive things. But there's also very good activity in JARIS, in ISO, and so on. So I think that the standardization world has woken up over the last 12 to 18 months and saying, hey, we really need to do something about this. This drone market, this drone industry is moving at a pace which is much, much higher than anything that we've seen in the past. So I think that realization is coming there.
I think there is one thing that will accelerate this. This is the marketplace. I mean, growing demand for, to making these good things like service delivery, like photography, like, acting in the disaster situation, this market will force parties to accelerate the tasks. This is my opinion.
Yeah, again, from the experience of both Poland, when we were first facing the need of that kind of system, we start our work development and deployment with DroneRadar. Afterwards, we asked our regulator to work with us about the regulation, and it is a good news, and by the end of this year we'll get a new regulation regarding BVLOS operation, and afterwards I believe that it will accelerate the operation because there is a recognized need of that kind of operation. Moreover, there is a governmental program about U-Space implementation which also facilitate all activities and involve all stakeholders, not only INSP. So I think that kind of activities will support and accelerate our acting.
Well, if I hear, you all seem to agree that one of the keys is demonstrations, demonstrating the technology, testing the technology. Do you have the impression that this is understood, that it is understood on an international level that we all have to share, and that all demonstrations that are taking place are actually made available, the results? Is that happening, or are there still guys that are hiding it?
Yeah, I do have the impression, and we're actively working towards that the tests and the demonstrations that are going on, that the results are made public. But I have to disagree that the demonstrations is just let's say testing the technology. It's much more than that. It's, of course. It's also testing how does an ANSP or a service provider use that technology in a day-to-day operations. I think from our point of view, there's already a lot of technology available, but that new technology defines a totally new way of working for ANSPs, which they're not accustomed to yet. So there's a big learning process there. The results of those tests will also be provided to aviation authorities so that they can learn from that and build regulations. And the last thing that some of those demonstrations envision is societal acceptance. We see that many of the tests and the trials that are going on have to do with transportation of organs and bloods and using drones in an environment where it actually benefits society. I think that many of the demonstrations that are going on and will be going on have the objective of creating more acceptance from the society towards drones.
A little bit of insight conversation we had on Monday, I think it was, the guys from Malawi, the civil aviation authorities there, they are doing blood delivery, right? And that's a real connection to the public overall interest and good. And if you can see that generation of ROI and connect that drives the need a lot faster. So comes back to the business case, I guess.
Yes, I think that this demonstration, the results shall be public, and in Europe I think that most of them are. And also, these demonstrations can be used for test the technology, but also I think it's very important that this new world of the UTM has multiple new players. There are all the service providers, there can be several, the NSP, the authority, the police that maybe want to create a geofence area. So we have a lot of new actors, and we have to test how they can interact in a safely manner to be able to put this in real operation in the real world.
Okay, Peter. Before we too wrap up this session, I will just ask them one question, but you just answer this question with one sentence, to be short. So this question comes also from the floor. I think that is quite important because I think probably our ICAO colleague would be happy to know the answer. What other options for engagement with ICAO would you like to see? Just one sentence to be short.
I'll jump in here. I'd like to see this more often. I'd like to see more, one sentence, more often.
Just one sentence. Okay.
I think I have to concur. That was my sentence.
Well, I also agree, more conference and more work together and consultation with the industry and all the stakeholders.
Maybe if ICAO would attend the tests actively, if they would observe and audit somehow what we are testing, that could be really also something valuable in my opinion.
I fully agree with all comments, and I think the ICAO should be more involved in the more operational aspects than regulatory only, so that would support the acceleration of this.
Okay, thank you so much for your suggestions. I hope this part will also be recorded in our report of ICAO. Peter, the floor is yours. You may wrap up on behalf of your side, and I will wrap up later in the Chinese channel.
Okay, thanks very much, Hao. So we've come to the conclusion of this this afternoon. It's been very interesting. It's been dynamic. We've had presentations from various countries, but apparently they're all thinking in the same direction. They have very similar opinions. This is good. We have to continue in this way. What came out at the end was really interesting. ICAO, be more involved with what's actually going on in the field. Now, that must be something new for ICAO. Maybe this can also be fun for you guys. But you need money to do that. So we have two things here. First of all, the member states should be paying their dues. That's clear. But maybe we should also look at the possibility of implicating industry to invite ICAO. Then they get what they want, you get what you want, but that's only if all the member states don't pay. If they pay, they will pay. So, guys, thanks very much for showing up. Thank you very much for having participated. Before I close and I give the floor to Hao, I have one request to ICAO. Please, in the future, don't put the girls at the end. Thank you very much.
Okay, thank you, Peter. I fully agree with your suggestion. Now I switch to the Chinese channel. 应该说呢
The two sessions in this afternoon, be it the traditional view and the non-traditional view, in terms of the UTM and ATM integration, it is hard for us to give you a completely clear, feasible answer which can be implemented tomorrow. So we need exploration, but there are 2 points that are very important. First, now we're in urgent need of a framework that can be accepted around the world, that can be coordinated. I know that colleagues from ICAO and USAG have been doing this, so I think in the future we really expect the birth of such a document. We hope it will be helpful to you. And the second point, which is also very important, is that whichever perspective we take, be it data provided by the ATM to UTM or the safety, efficiency, safeguard of the UTM system, the information and information network are critical in this area. So it means that our information is reliable, sufficient, and the transmission process is reliable. We know that ICAO colleagues have been engaged in this, and I believe that in sessions tomorrow, you will hear very useful information and solutions. And once again, a big thank you to all of you for participating in today's sessions, especially our speakers, because this afternoon we have two groups of speakers. I would like to thank the traditional group and the non-traditional group. Thank you for your work, and thank Peter for your very good proposals and suggestions. Thank you.
So I'd like to thank both of our moderators for taking us through this afternoon's program and material, and to this particular group of non-traditional presenters, thank you all very much for engaging in a reasonably provocative discussion about some of the challenges that we face. So we're going to do a little bit of a change out here, but before we do, I want to just give you a little bit of a taste of what I'm feeling, having watched some of the presentations and following on from Drone Enable last year when we kicked this off. Drone Enable is different for ICAO, and it's different because of necessity. As Peter noted, there's not really a program that was paid for by the states that when they asked us to start to address this challenge, because they didn't really know how to do it. They didn't know what the scope of the problem was. But one of the things that I think that the team did that was truly innovative was to surround themselves with people who are way smarter about the forthcoming technology through the request for information process. So we're hearing presentations from people here who actually are in the business. As Peter said, they're the people in the field doing things, and they're the ones coming to us and saying, here's what you need to think about doing, regulators, so that we can move this industry forward in a way that will be efficient, effective, hopefully profitable, and also integrate safely with traditional aviation. So to do that, we have to surround ourselves with smart people. And I think that that's a characteristic that is part of what has made aviation truly great in the way that it has delivered a safe, risk-free outcome. And now, though, we're having to increase the tempo and do that more quickly. So we'll talk more about that as we go into the program tomorrow. But again, a big round of applause for our presenters. And then I'm ready to introduce our last final speaker. Thank you very much. Now, while our panel is coming off stage, I'm going to introduce a gentleman who is known to many of you, but for some of you, this will be your first time to see him in all of his glory, I think would be the best way for me to say this. So we have a special presentation on the new ICAO Global Aviation Trust Framework concept and proposal. It has a goal of enabling innovation and interoperability. So a lot of what you've heard about today in the panels is about connecting things and connecting people, and doing it in a way where you can share information. So when you share information, is the information correct? Is the information accepted by a regulator? Is it fit for purpose? Those are questions that are very real questions for an aviation regulator, and it's part of what we have to assess when we develop new proposals. Our presenter on this issue is Mr. Bill Voss. He's a special advisor to the Director of the Air Navigation Bureau, in other words, special advisor to me. And that's, again, a matter of me surrounding myself with people who are way smarter than I am. Bill is a licensed airline transport pilot. He's been an airline mechanic. He's been an air traffic controller. He's been a provocateur, and he's worked in aviation for about 45 years. He has served as a senior executive in the FAA. He has been in this role prior to me. He served as an air navigation commissioner, and he was also the president and CEO of the Flight Safety Foundation. So he's somebody who's been out there in the trenches where the issues are being worked. It's my pleasure to introduce Bill Wallace. Come on up here.
All right, well, thank you, everyone. So that was quite a session, and I thank you for it. Now I have the tricky part of trying not to sound like a dinosaur, but instead trying to sound a little bit like someone that's wise. Because, you know, let's be real, we've been talking for a long time about drone and integrations, but it's always been a conversation about the new entrants over here and the existing system somewhere else. I'm going to try today to talk like we're one family, honestly and openly, about a family meeting, about the challenges we all face together, and the really wise choices we need to make. So let me try that. This is a conversation about a trust framework, which is a bit of a technical topic, but I think I'm going to use it to explore some real fundamental issues. If I can make this go there. So first thing, I'm going to have to admit that this traditional aviation system is facing a lot of challenges. You may assume that it's some big, powerful giant that you have to bow to, but actually the giant's tipping over a bit, and maybe we can find some solutions together, being stressed by growth, capacity and efficiency demands, trying to deal with the digital transformation on a scale and the speed we never anticipated. Yes, new entrants, and not just the new entrants below 400 feet, but multiple new entrants. A cyber threat that we're a bit slow to respond to. So that's the first bit. You know, here's a picture of the traffic density of the world increasing. I don't really need this picture. We're in China. I think we know something about growth and traffic density. And the only way to meet this demand is going to be a transformative reliance on exchange of information in the ATM system. It's the only way we can optimize and deal with this. There's a digital aviation ecosystem that's emerged beneath our feet. Every aspect of the system, you know the digital experience you now have at an airport. Take a look at some of the other things that are less obvious. A 787 has 500 safety-critical software components installed in 900 locations if you don't count the engines. Someone's got to make sure that it's secure. It's all got to be managed in a reasonable way, and that goes on and on through the entire ecosystem. And then, of course, the new entrants, which aren't just the world of the drones we're talking about today, things that go high and fast, spaceships plummeting under autonomous control to the ground, things flying very high, very slow, very high, very fast. And of course, this cyber threat. When you make things digital, you make things vulnerable to this threat. And it's a constantly evolving threat. And if ICAO tries to get into the details of dealing with this threat, it'll be a tragedy. We can do the strategic, we can do architecture, but others have to get into the day-to-day. So we need to do what we do well and know when to stop. Every state, every operator will have to respond to emerging threats, but they should be able to do it with an architecture that makes sense. So right now we have a family of diverse operations, and they're divergent. They have to secure themselves. They have to deal with this new digital world. Airports, ATM. You just had a conversation about UTM, ATM. We're now having a conversation with at least a dozen different entities like that. And they're all doing things to secure their systems. And they should. But the challenge is that as we get hundreds of different actors coming up with hundreds of solutions and digital certifications, identity tools, you end up with a system where you sacrifice the interoperability that we need to go forward in this century. So it's time for ICAO to try to find a middle ground between the innovation that we need and the wisdom that we're founded on. So let's talk about what might be a converging strategy. What do you do if you're in ICAO as part of this big family at the head of the table? You recognize that interoperability requires global cooperation. And that's with everyone, including the new sector. We can't talk about you as new entrants, really. You have a seat at the table because you're sharing our sky. We have to find common needs that can unite a very diverse community. We believe there are common needs. We have to develop common solutions together. We can be different where we need to be. We can innovate where necessary, but we need to start building on existing foundations and moving in a common direction. And we need to give this new group, this new group of innovators, a real seat at the table and room to innovate. You're not forcing your way into this family. We're actually counting on you. We have challenges that we're facing through all parts of traditional aviation that are going to require innovation. We need you, but we need to find a way to work together. We need to agree on a common destination where we have one interoperable sky at the end of the day. 70 years of leaders have gone before us in ICAO, and they've always handed us that one precious thing. We need to find a way to do the same. While we have this diverse ecosystem, we think something that maybe ICAO can contribute to without muddling up would be this issue of identity and trust. Because, of course, in the digital world, if you don't have a robust system of identity and trust, you don't have really any way to communicate digitally. So we're talking about a trust framework, and those of you who are in the network world know that this is not exactly a new or thrilling idea. I'm sorry, we're ICAO. We don't necessarily do cutting edge. That's why we're here talking to you and listening. But we do have some tools that we can bring to a trust framework. We have a foundation of international law, which can be rather convenient, by the way. Always nice to have a treaty to refer to. We have some regulatory processes that can really help make a robust identity. And we can also have the capacity to put in place a trust bridge. We are actually in a central place in the system. So let's talk about that first bit. And let me tell you a quick story that I think is useful. So ICAO, for those of you who are new to us, 1944, some people got together in a conference room in a hotel in Chicago. Many of them were actually refugees because a new disruptive technology called aviation had just been used as a tool to level a lot of the capitals of the world, including some of the capitals and the homes of the people who were at the table. And their challenge, as this war was beginning to draw to a conclusion, was how do we take this disruptive technology and use it in order to rebuild the world that's now in ruins? And how do we use it to connect the people of the world to make sure it doesn't happen again? They came up with the first trust framework. They set up an organization that does international standards, and those standards are then used by authorities, civil aviation authorities in this case, to issue certificates. And when those certificates are issued, because they're issued to these standards, other authorities recognize those certificates and trust is established. It's old-fashioned, it's not digital, but actually it's very much like the trust framework we have today. The thing that's different, and the thing you need to understand, is you learn to work with us, as old-fashioned as we are, is a lot of this trust still flows from the regulator. I mean, There's millions of hours spent across this vast ecosystem where regulators are in conversation with operators. They know a lot about each other. It's a difficult thing to hack. It's ultimate two-factor authentication. A regulator is not going to authorize a certificate to someone unless they understand what's happening and why. And so you can trust that interaction. It's not just a burden. Take a look at how many things there are that regulators are already approving, certifying, licensing. And so if you just go back and say, well, all of those things that are now in paper, how about if they come with a digital certificate along with it? You can be pretty confident that that's only going to be issued to the person who's actually supposed to have it. We're already paying untold millions for it. Why not build on it? And let's face it, there will be regulatory roles in this new world as well. And so maybe we can leverage it and find a way to help it build trust. There's the manual process. One state flying the blue flag issues a pile of certificates. They paint a license on an airplane that's inspected by someone and is honored. Let's talk about where we need to go then. Now, this is going to be the controversial part. This isn't very flashy. I mean, we can talk about multiple ways of establishing trust and exchanging trust, but we do know that there's an awful lot of people invested now in PKI. We can move forward. We need to have a system that's agnostic to the source of trust. Let's start here. We already have this in use in a lot of places. Avionics manufacturers, airport operators, lots of people are going this way. If you plug the state into the process, there's some real power behind those digital certificates. We can do better than just relying upon, as a basis of trust, Komodo or VeriSign. We can anchor trust more robustly by combining the old system and the digital system that exists today and finding a way to evolve it into the new technologies that we've already discussed here into the future. And so basically it's just take the old trust system and add some digital certificates, maybe put them in one central place so that as our vehicles move around the world, there's a central lookup point, the trust bridge, where you can go back for a central source of identification. The proper term, a bridge certificate authority, if you want to use networking terms. So that's a start. But let's also talk about some things ICAO might be able to do that could help all of us, maybe even you guys with the amazing technologies. So it's great to have this identity and trust, but if all you have is a couple bits of trusted data floating in a vast ocean of kitten videos, pictures of last night's dinner, and text messages, that's not a very robust system to anchor the sky, if you will. So we're doing some things now that we think only ICAO can do on behalf of the global system. And we can have a conversation about what this might look like. But here's a couple things. Because ICAO has this broad reach across all of the bits, we're talking to ICANN, Internet Engineering Task Force, about things like a large IPv6 address block that would be dedicated aviation, a top-level domain, dedicated aviation, that could provide some level of logical separation from all the noise around us. Not a real flashy idea, not an end-all solution, a bit of a 1990s approach, but it certainly would make our world a quieter place from the cyber perspective, much like the finance industry does. It's a beginning, but all ICAO can do is try to provide an architecture under which people can interoperate. So let me just summarize quickly what we're thinking. Basic steps. Clearly, this idea of a trust framework resonates with us because we probably have been doing a trust framework without the benefit of digital for 70 years. And we're all here. It's actually had a pretty remarkable effect. Those people in that conference room actually did manage to use a disruptive technology to rebuild the world. Here we are. So we're looking at things like top-level domains, block addresses, things that we could try to do to make it a little bit safer, to give the world, all of you in architecture, a place to play where we could find a way to innovate and secure and enable global interoperability, give it to the next generation like they gave to us. So there's choices to be made here, and I want to phrase this very carefully. We understand and embrace and we appreciate the entrepreneurial spirit, the desire to innovate rapidly and be independent, the desire to get the winning technology that becomes the standard and makes you rich. Not a bad idea, but it does mean you get a longer path towards integrated operations. There's the other thing we can do, and this we hope this isn't a painful choice. We'd like to collaborate and talk about what we could do to find things like a common source of identity and trust, common network attributes, so that we don't end up with 100 different solutions or even a dozen different solutions unique to each part of the infrastructure. Because the extent to which we do that, the opportunities that we cannot even imagine that will present themselves in the future for integration, they're very exciting. So let me summarize and get us out of here at a decent hour. All decisions have consequences, and I want to go back and remind you of some of the wisdom I think we've learned in ICAO. Back in 1944, there was this understanding that it was immensely powerful to have a single sky that connected every human being on the planet, a single point of tangency that touched the face of every child at any given moment. That is an amazing idea, and I'm proud to have served with people who have spent their life trying to pursue that idea. It's tested every day. Every time there's been a war, a new technology, a change of a boundary, a disease being spread by aviation. Things like, the jet age, introduction of spaceflight, introduction of digital communication, introduction of GPS. All of these things were seen as disruptive, and the first instinct was always, let's isolate them. Let's lock off this route. Let's isolate this region. Let's avoid the problem. But there's always been a dedication and a wisdom to take the time to find a solution where even if you have to be segregated for a moment, for the rest of eternity, there would be a path where you could unite and retain that incredible thing of a single sky that has changed our lives. And so I ask this one provocative question as you go off to dinner. I love the inventions, but will we ever really invent something that's more important than a sky that touches the face of every child at once? And so the challenge really is that makes us better, that makes us one family. The challenge is to find a way to do innovation and serve the idea of a single sky. You see a lot of these slides have this words like ICAO, Uniting Aviation. It's because that's what we actually do. Thank you.
Okay, thank you, Bill. I don't think I could have done that any better than. So, ladies and gentlemen, thank you for participating in a very interesting day today. Beyond Bill's question, which I think is a really important question for us to focus on, is the idea of how all of these innovations that you're talking about can lay on top of a trust framework like Bill is proposing. I think that is exactly what we brought this presentation here for, because we believe the people in this room have the opportunity to leverage that thinking quicker than anyone else in the aviation family, and to be the leaders in thinking about how to bring that through to the regulators around the world so that you can actually realize global product from each of these local demonstrations that you're doing. So tomorrow we'll get into more detail about how we can engage together to make that possible. But again, thank you all for your participation. Have a great evening. We'll see you here tomorrow morning.